Welcome to the Master the NEC podcast, the ultimate destination for anyone passionate about the electrical trade. Whether you're a seasoned electrician, an eager apprentice, or just someone who wants to dive deep into the world of electrical work, you've come to the right place. Join your host, Paul Abernathy, a true authority in the industry with over 38 years of trade experience, as he electrifies your mind with in-depth discussions, expert tips, and valuable insights that will keep you ahead of the curve. Each episode, Paul will illuminate the complexities of the trade, decode the National Electrical Code, and share the latest industry trends, all while empowering you to take your electrical career to the next level. So, gear up, plug in, and get ready to supercharge your knowledge, because with the Master the NEC podcast, the power is in your hands. Now get ready. Here is your host, Paul Abernathy.
What up, everybody? Hey, welcome to another episode of Mastering the NEC. My name is Paul Abernathy. Thanks for joining me on this podcast. Remember, you can listen to all of our podcasts, and we have 3 of them, by the way, on any of your favorite podcast listening platforms: Spotify, Spreaker, Deezer, iHeartRadio, Apple Podcast, Amazon Music. All you got to do is search for the podcast, and we've got 3 of them. So you could search for Master the NEC podcast, all separate words, Master the NEC podcast. Or you can look for the Let's Ask Paul podcast, just Let's Ask Paul podcast. And our newest podcast is the Bond and Ground podcast. That talks about Article 250 and all things related to grounding and bonding. We dispel these myths that you see floating around out there and all those other good things. But the podcast, we have over 1,000 plus episodes that you can listen to, dating back many years, still very relevant. And so check them out. And if you want an easy way to listen to our podcast or stream them to your other devices via Bluetooth, is just go get our free mobile app. It's free. It doesn't cost you anything. And we don't push anything down your throat. You don't have to download any bloatware onto your phone. Or anything like that. Just go to fasttracksystem.com and you'll see in the navigation, it'll say mobile app. That's our main website. And check it out. And you load it on your phone and you can get access to our blogs. We have some great blogs, really educational blogs as well. It's always great to learn. I believe reading is still the way to do it. We watch a lot of videos. I get it. I do this morning shows every day. I know it's very visual, but I am still a believer that you have to be able to read something to comprehend it. And so that's what we got going on with the blogs. And of course, you can watch Coffee Hour directly from the mobile app. You can listen to the podcast directly from the mobile app. And you can access pretty much anything, even our chat feature for those that have the mobile app only on the mobile app. So that's pretty cool. You can attach pictures and upload job site pictures and ask questions on it. So it's a really great platform. Take advantage of it. You do have to register separately over on the mobile app. Okay, so you might be a student. You might be in one of our other programs. Maybe you're a subscriber or a Fast Tracks 2 platform. All of that type of stuff. But at the end of the day, you have to register separately on the mobile app. All right. So let's get to business here. Y'all folks want to get to business. So I just recently came back from the 2025 NFPA NITMAM conference in Las Vegas, Nevada. I'm not a big Nevada fan or Las Vegas fan. I guess because I've been there so many times. It's like, really, I'm not a strip guy. I don't walk out on the strip. I hardly ever leave the hotel. And usually, I know I say this before, usually when I'm on business trips like that, I am so business focused. I'm not there for me. I'm there for the business that I'm representing. So in these meetings, I was there, and in the meetings, I'm trying to engage in the debate that's going on these different CAMs. CAM, by the way, is called Certified Amending Motion. They're part of the NITMAMS process. And they're making potential amendments to the public comments that were submitted during the code development process. Y'all all know how that works. You got public inputs where any of you can submit things to the NEC, and it'll be reviewed by the code panels. If accepted, it'll go into the published report. And then, of course, you can make comments on those things that make it through that maybe we didn't get it right, or maybe you didn't like how we did it. Okay. And then you get to make comments on that. And then, of course, the next stage is once that's published, you got what's called the NITMAMs. And the NITMAMs are notice of intent to make a motion. And then when you go there, you're actually writing what's called certified amending motions. And you're amending something to the public comment. And they're making a motion to either accept the public comment or reject or fail the public comment, that type of thing. So they're trying to amend or change or do something that came out of the public comment stage. Again, it's your third attempt at fine-tuning something for the NEC, because now once this is gone, there's still some minor voting that takes place, correlating committees, work gets done, and next thing you know, it'll get published and will be in the next edition of the NEC. And then states will start to slowly adopt it, usually within a couple months. In many states, it takes longer, but usually within a couple months, you'll get some of the bigger states, like Massachusetts. Not that it's a bigger state, but being where it is, it'll try to adopt it first. And then you'll get Texas, usually around September of the year that it publishes, or the year of the book, which is it's 2026. So usually around September of 2026, they'll adopt it in Texas, and other states will follow, some quicker than others. So kind of your last bite at the apple, if you will, here in Vegas this past week. And there were quite a few CAMs. I don't think there was as many as it used to be. I mean, it was a little more reserved. I think, maybe I'm wrong, but it just seems like it wasn't, nobody was in a big rush this time. And that tells me that the agenda just wasn't as beefy. But again, a lot of good things, a lot of EVSE stuff on the ballot. And of course, a spattering of other things on the ballot that we're going to talk about a few of them today. Obviously, I can't talk about them all. The CAMs will come out once it's all said and done and all the dust clears and everything. So I'll talk about a few today to give you things to think about and hopefully encourage you to get involved in the process. So you might not agree with everything that gets done at these meetings, but if you don't go or you don't get involved or you're not a voting member, you really are just kind of just watching, and everybody's entitled to an opinion. But again, that's what I said years ago. If I was going to complain about something, I had to get involved. So anybody, you listening, you can submit a change to the NEC. You just need to make sure that it is well-founded to have a good chance of being accepted by the code panel. Because these are a panel of experts, whether you like it or not. Everybody that sits on this panels, the code-making panels, has an area of expertise. They might not have expertise in everything that is talked about on the panel that they're a member of, but they have a good level of expertise, and it kind of helps balance out the committees, right? Or the code panels. So again, it's a fair process. Can the system be gamed a little bit? Yeah, not by any other reason except for certain people may have certain agendas, but they have what's called influence. Means that the members of the committee or the panels actually weigh their opinions very highly. And so that can sway some of the individuals that may not be as knowledgeable in a certain topic. But they look to the people that are at the table that are, again, viewed as experts. And so that has influence. Now, you're not going to get rid of that process. It just is what it is. It's just the way it works. You have influence in anything that gets done. So, and we need these people. We cannot have people at this table, the code panel members, we cannot have people that are not considered expert in there. So they're going to have various opinions, agendas, motivated factors. It just is what it is. It just can't get any cleaner than that. There's no way to, people say, well, it's not a fair system. It's gamed by the manufacturers. It's not gamed by the manufacturers. Now, do the manufacturers have influence? Absolutely. Absolutely. Just like any other expert that were to go there and speak on a certain topic, they've got influence, right? And they would be foolish not to use that influence if they have some kind of mission they need to achieve. Now, you would think that at the end of the day, it's all about just electrical safety. We put all that aside and we're simply voting what's good for the industry. That does happen for the most part. Most people, do that. Very few people go in there with agendas, but again, influence is going to rule. And if they're very influential, a lot of manufacturers are very influential. A lot of people that serve for these manufacturers, they're not foolish. They put influential people in positions to be influential. It just is what it is. So whether you like it or hate the system, get involved in it if you want to see change. If you don't want to see change, then sit back, stop bitching, and just take what you get, but you got to be involved. So during this process, there were a few cams that it raises a few eyebrows on some of the stuff, but again, we'll talk about a few of them, and then I'll just kind of give you a few things that took place. Now, one of the first ones I'll talk about, this CAM, or Certified Amending Motion, was to accept a public comment, which was 1854. And they want to accept it. And in this one was talking about the minimum number of branch circuits in a dwelling or in dwelling units. So they wanted to establish the minimum number. As you might have heard, the load calculation under Part 3 of Article 220, which is going to be 120, by the way, in the 2026 edition, so it's moving around a little bit. There was a big push to say, well, since we're lowering it to 2 VA per square foot to do a load calculation and let that cover all general use receptacles and general lighting, that we wanted to make sure that we at least established a minimum number of branch circuits for the dwelling unit. So 120.13 attempts to do this, and there was we're so used to 3 VA per square foot. And that's what was proposed, and that what was in there also to establish for the minimum number of branch circuits. Even though we're dropping it to 2 VA per square foot for the load calculation, when it came to the Part 2 of 220, which is now 120, to establish the minimum number of branch circuits, minimum number. Now, again, not including small appliance. That's already covered in 210.11, which is going to determine the minimum number of that. And we've got those rules for the VA per square foot covered in what was 220, now 120. We already have that. This was really to determine the minimum number of branch circuits when calculating the required number. And it was it was 3 VA per square foot. That's what was in the code. That's what we pushed forward. That's what's going to be in the 2026. But then there was this CAM, because a public comment was trying to increase it to 4 VA for calculating the minimum branch circuit required. And I think at the end of the day, 3 VA is what we've always used. Prior to this, there really wasn't a minimum number of branch circuits. Prior to trying to establish a minimum number, you knew what you had to have. You base it on 3 VA per square foot, and then of course you include in there the minimum of 2 small appliance branch circuits at 1,500 VA each, and then the laundry at 1,500, that type of thing. But really, it didn't seek to demand the minimum number of branch circuits that you had to have. Again, not including the small appliances and laundry, other circuits. Okay, we're talking the minimum number of just general use, general branch circuits. It doesn't really say general branch circuit. It just says in dwelling units, the minimum unit load shall be not less than, and it gives you a volt ampere value per square foot to use. So the effort here was to establish a number, because with the reduced value per square foot for the load calc, the risk was that it wouldn't be something where we had adequate number of actual branch circuits. So this is an attempt to try to establish a minimum number of branch circuits. Again, not including the already required branch circuits, which are different. Appliance branch circuits, things like that. So it was 3 VA, but in the public comment, it was to increase it to 4 VA. So this CAM was to accept the public comment of 1854 in order to increase it to 4 VA per square foot for calculating the minimum branch circuit required. And it passed in the CAM meeting here in Vegas. So they increased that to 4 VA per square foot. And so, again, many people were on the forum. I posted this on social, and people are like, it looks like we're going in the wrong direction. They're dropping the overall load to 2 VA per square foot, but they're increasing. So all this was just a tried effort to push to make sure that you have a minimum number of branch circuits so they're adequate, that type of thing. For me, it's going to make more branch circuits. This means more breakers. This means, a bunch of other things, but at least it does give us a value. So if somebody asks you a question about like an exam question in the future, a minimum number of branch circuits, well, you have to remember that the general use is now going to, into 2026, it's going to be based on 4 VA per square foot. You're obviously going to use the outside dimensions of a dwelling unit, just like you always did. But when determining the minimum number, you're going to be using that 4 VA per square foot now. But you also have to remember, based on the question, you still have your small appliance requirements, minimum of 2. You have your laundry, all these type of other things that you still have to consideration. So in a question about asking you how many branch circuits are required, now you got to think there's going to be some minimums that you have to have. Okay. So, now it's going to be, again, like I said, based on 4 VA per square foot. Okay. All right. So that's that one. Let's see. What else do we got? Okay. The next couple we'll look at is expansion of AFCI. So what we have is in the 2026 edition, we're adding some additional locations to the list in 210.12b. So the first one that they discussed in the meetings is CAM to is actually a committee comment, 7743. And the committee had recommended that attics be added to the list. Okay. So it basically, if you have a 120 volt single phase, 10, 15, or 20 amp branch circuit supplying outlets or devices installed in the following locations shall be protected by any of the means described in 210.12a, which is a list of the different options you have for AFCI protection. But in the branch circuits, and this is very much a branch circuit requirement, okay, that's what, arc fault is about the circuit, whereas GFCIs in 210.8, A and B, for example, are about a receptacle. So attics was added to the list, and so any of your 10, 15, or 20 amp branch circuits, and we'll talk why 10 is going to be irrelevant in the future. I'll talk about that later. But anyway, these branch circuits, if they're supplying or going into the attic, into those locations, then they're going to be AFCI protected. Now, reality is probably most of the circuits that were going up and through an attic anyway, we're probably going to a location that required AFCI protection on that circuit anyway. So probably not a massively impactful change. Well, it will change is that if you are running a circuit up into the attic for whatever reason, then it would have to be AFCI protected. So I don't know that this is that much of a big deal of a change, but it is adding another thing to the list, which again, I don't personally didn't hear enough justification for it. When somebody says that, a house burnt down because of a circuit in the attic, I sometimes question the data because I'm looking at it going, okay, was it installed when there wasn't a requirement anyway to have it? So it was compliant at the time of installation, but we have one fire. All of a sudden now we're going to throw attics in the mix. I don't know. But again, what's the difference in hallways? What's the difference in closets, right? What's the difference? So at the end of the day, attics has been added to the list. And for those that are looking these things up, this is CAM 70-88, by the way. If you're these are all available on NFPA's website. This is not inside knowledge. This is all available, publicly available for you to look at. And so again, you can check that out. But again, the effort there was to get attics added to the list. And it succeeded. So attics is now in the list of 210.12b. So any branch circuit that's going to be running 10, 15, or 20 amp branch circuit that's going to be going into the attic, then again, if it's supplying outlets or devices installed in the attic, okay, not necessarily on a circuit that's not required to be. I'm going to give you an example. So the circuit for the receptacles, let's say, for the bathroom receptacle circuit, okay? that could go up and through the attic and then down, let's say, into the bathroom. There's nothing in 210.12b that lists bathrooms when it comes to like receptacle applications. Okay. There's nothing in there that says, oh, well, it goes through the attic. No. This says all 120 volt nominal single phase 10, 15, or 20 amp branch circuits supplying outlets or devices installed in those locations. So this is going to be germane to any lighting outlet that may be installed in the attic, or any receptacle that's going to in an outlet box that's installed in the attic, that type of thing, which in all honesty is probably being supplied by a circuit that already has AFCI protection, like popping off of the hallway receptacle and just going up in the attic, or off of a bedroom or living room, or something like that. So it's probably already, but it's just making it very clear that it has to supply. Now, for those that run the home runs, okay, very common to people to run a home run up there and hit a lighting outlet. And also it may power smoke alarms throughout the house through that circuit. And so again, if it's going to go up and hit an outlet, and again, let's not confuse outlet. There's old folks, the style cups and the whack hackers, or what's his name? Willie Jackson, whatever, Fakerson, whatever the hell his name is, who believe they don't understand the definition of outlet. They still don't understand the definition of outlet. They tried to get that changed. It was woefully rejected because it's very important that we understand that outlet is a very broad term that we need to understand as professionals how we use it. A receptacle is a device, totally different. So in this case right here, it's just important to remember that if that circuit stops at an outlet or device in the attic, then it's going to be required that has AFCI protection on it. Again, that's not going to have anything to do with a cable from a circuit that's not required to have AFCI, that passes up through the attic and then down to wherever it's going to go. That's not what this rule is about. So just kind of keep that in mind. Okay, the next one, sticking with the AFCI concept here, or the topic of AFCIs, is CAM 70-89. Now, the last one, again, was keeping them together. The last one was CAM 70-88, by the way. So this is CAM, Certified Amending Motion 70-89. In this one, they seek to add the term bathroom lighting outlets. So this is, again, now we're introducing the bathroom, but we're only introducing the lighting outlets that are in the bathroom. So you're lighting over your vanity, you're lighting in your ceiling, those type of things. Just the bathroom lighting outlets, not your exhaust fan, that type of thing. Now, one of the things here, it may not be as impactful to many people because they say, look, the bathroom lighting outlet, I just pull it off the bedroom that's next to it or the hall anyway. I don't have to run anything special for the lighting. Okay, it's not like that's got to be on a 20 amp branch circuit, just like the receptacles that are in the serving the basin or the sink in a bathroom. We're not talking about that. So this is the bathroom lighting outlets. Now, how can this impact the receptacles in this room? Well, how it would impact it is if you're using the exception where I'm running the ability to be able to do both the lighting and the receptacles inside of a bathroom because that circuit doesn't leave that bathroom. Well, if you're going to run that one circuit and it picks up the receptacles, which obviously have to be GFCI protected, but it also now picks up the lighting outlets, that's going to change the story. You're going to have to go with a dual function and utilize that, which dual function is going to cover GFCI and AFCI. That's an easy way to do it. You can have an AFCI breaker and have a GFCI receptacle and still comply. They work very good together. I think something that was a little unnerving, and I'm not being picky here, and I'm not calling out anybody, but when a manufacturer who's promoting these things and pushing these, and again, the bathroom lighting outlet, some obscure issues somewhere in the country where maybe one of those circuits calls something, and I'm like, whatever. I mean, again, we're we can't take one incident and change everything. And sadly, we sometimes do that, or people use it as ammunition to change the code. And I'm like, dude, it's just one incident or an isolated. Things are going to happen. We don't need to change the entire code because of something like that. But anyway, obviously something happened. And so they introduced this bathroom lighting outlet. But what was concerning to me is when the manufacturer, a leading manufacturer of these devices, came to the podium and called the AFCI and GFCI devices, he called them combination. Now, y'all been listening to me for years, and y'all know that that is not what combination means. It has nothing to do with AFCI and GFCI. Combination has to do with the detection of parallel and series arcs. That's big difference than something that would be like a dual function that's functioning as a GFCI and also can simultaneously function as an AFCI. Big difference in terminologies, but when you're going for credibility and the manufacturer is the one that's at the mic pleading for expansion, you would think that they would take the time to understand that there's a difference between a dual function, there's a difference between combination, and they're not the same. And in the context of the way he was speaking, he was talking about AFCI and GFCI, and he called it a combination. Again, could be just a Freudian slip of the tongue, but when you're a manufacturer and you're in the room of experts, you do lose a little bit of credibility when you hear that, because you're like, dude, you're supposed to be the expert for your manufacturer, and you're not sure what a combination really does. So I'm just saying it out there. I'm not mean. I'm just saying it. Most people it would say, yeah, we know what they're talking about. We're not going to argue that. I get it. But some of us that are, looking at these type of things really kind of focus on that type of rhetoric, and it's important. Okay, let's see here. What's the next one we want to look at? Okay, there were a couple CAMs that were submitted to add a new conductor for things like the concrete encased electrodes, and that was a 40% copper clad steel conductor that was to be added to one of the to be the actual connection. So y'all are familiar. When we use concrete encased electrodes, we use either 4-gauge copper, 20 feet in length, or we do rebar, 1/2-inch diameter rebar, right? Okay, so not less than 1/2 inch. And one of the other methods was we could use bare copper and be 4-gauge and at least 20 feet. Well, there was an introduction here to try to get 40% copper clad steel as a conductor to be used with the connection for these concrete encased electrodes, or to be used as 20 feet of 40% copper clad steel conductor of 4-gauge. And that was withdrawn. So that was a 70-38. And again, so that was for concrete encased electrodes, the ability to be able to use 20 feet of 40% copper clad steel, no smaller than 4. That was withdrawn, so that's not going to be in our code for that. Okay, so that one took place. Same thing for ground rings. There was a proposal to introduce, whereas ground rings, you have to have at least 20 feet of bare copper, not smaller than 2-gauge. Well, there was an introduction of a CAM 70-41 that was going to introduce 40% copper clad steel as a conductor that could be used as a ground ring. That was withdrawn as well, so you're not going to see that. It's going to be just copper, and it's not smaller than 2-gauge, so we're talking about ground rings. That is 250.52A4, by the way, for those that are following along, and that was based on a public comment 193, but the CAM was withdrawn at the last minute, so you're not going to see that in there. Let's see here. What else do we have? Okay, the next one that we'll look at was a quite lengthy debate that went on talking about surge protective devices. And I think the crux of this argument was that the code panel feels that if you had a dwelling unit, whether it's a single-family dwelling or not, that 230.67 requires that you have SPDs at the service, right? So this one is under 215.18a. So this means that if I have even if it's a single family dwelling and I have a remote service, means it's away from the structure. It doesn't have to be on it or in it. It can be remote. And I've done that before. And so you end up having a feeder that's going to the dwelling, okay? But the SPD is out at wherever the service is located, that type of thing. And so the submitter during the public comment stage, 1938, was the home builders, and they were like, well, we wanted to say surge protection on the feeders to dwelling units of multifamily buildings, so it could only be required for those multifamily, which is 3 dwelling units or more, that those were the only ones that required the surge protection on the feeder application. Now, remember, 230.67 already requires SPDs at the service. So his attempt, or the submitter's attempt, was to say, look, you only need the SPDs for the dwelling units that are supplied with a multifamily building. So basically, if I have a single family dwelling and the service requires an SPD, that they want it at the dwelling. And in the code panel members, or this, they rejected this and said, look, if you add that of the multifamily building, then that means it's going to leave out those folks that have this single family dwelling that has the surge protected device at the service, which may be remote from the dwelling. And they're supposed to monitor it and look at it and check it and do all this kind of stuff. But if you did it that way and you added that of a multifamily building, then they would not be putting the surge protection device at the feeder location at the dwelling unit. And then they were worried that that would raise a safety concern. So here's my thing. I would prefer to have a surge protected device out there wherever the service is, even if it's remote. If a SPD does its job properly, then I will know. It's every homeowner's responsibility to know where their service is. It is, there's really nothing that they do to that. It's responsible ownership. Hell, they don't even know what to look at when they go in their panel. So we already have a requirement for the SPDs to be on the service. And just because on a dwelling unit, it may be remote, because maybe it's a large, single family dwelling and it's not mounted on or in, maybe it's a remote. If it's required to be in 230.67 at service, the whole issue here is I don't think, and you already have an allowance, by the way, in 230.67 to not do it at the service. You can do it downstream. So you could already do it at the feeder location. Obviously, if that service is supplying, and that feeder is supplying the entire dwelling because it's remote, then you do have options to do this under 230.67. So that's already covered. So the problem that we have in 215.18a is there's so much confusion where people send me all the time and go, okay, it says feeder dwelling unit. So what happens, Paul, if I have a service outside and I'm feeding a feeder panel inside, do I now have to put it also on the panel inside? And so I think it just becomes confusing for people. I'd be honest with you, in the code panel, when they rejected this, their response was that just like GFCIs, just like breakers they have to reset, just like replacing batteries on smoke alarms, the occupant has to have the responsibility. Well, I also believe that the homeowner has the responsibility to know where the hell their service disconnect is. And if it is remote, behind a board 20 feet from the house, behind a wall, because they don't want it to be in view, that's where the SPD goes. And they use the exception to put it downstream at the feeder panel downstream if they want. They use the 230.67 allowance to do this. And that is up to the designer. They can put it in the service equipment or they can follow the exception. This, to me, 215 needed to be more addressed to those situations where the occupant does not necessarily have access to these things, whether they're supposed to or not. For example, in multifamily dwellings where they really don't have access to to their service disconnect. They have access to what's in their unit, but they can't get down into a locked equipment room, which is still accessible to qualified persons because it's behind a key. Okay, those that need to get there. But I don't think it, and I've seen it tenants do not have access into those rooms. They have access to the panel that's in their unit. So I think that it just personally, we missed the boat on what was trying to be done here. I think that if you're on a single family dwelling, it is incumbent on you to whether your panel service is not on your structure or in your structure or remote. And if that's where the SPD is, then surge protected device, then it's on you to understand where that is. It's your home. You need to be fully aware of the systems that are in your home. If not, you hire a licensed electrician to do this stuff. You don't go screwing with it. Okay. If the SPD gets taken out, then again, you know, you're going to call an electrician. It's not something you're going to mess with anyway. Plus, again, you can negotiate this with your electrician that installs it. He could decide to put it, if it's a remote service equipment, you have an allowance in 230.67 to put it downstream. You do have the ability to do that. So to me, this one really should have been reserved for the dwelling units that are where the occupant can't really get to where the service would be, in my opinion. So again, probably could have been a little bit better, but we had a lot of people come up to the mic passionate about if my house burned down, if it wasn't for the SPDs on the dwelling units. This was not removing the SPD requirement for the dwelling unit. This was just clarifying the application. You already have SPD requirements in 230.67 and an exception to allow it to be downstream in the case that they brought up for the feeder. You already have that allowance in there. So I didn't see this. This didn't make sense to me. I guess somebody can explain why it's a big deal, but to me, we already have the requirement for SPDs at dwelling units. So I think we needed to focus on where we probably aren't going to have SPDs, and that is in the individual dwelling units of multifamily buildings. That's probably where we're not going to have any SPD. I'm just saying. So anyway, we already have that covered in my opinion, but anyway, it's what it is, what it is. So that was CAM number 70-79 for those that are following along. And so all it did was just revert back to the way it was in the 2023. No big change. It just was trying to clarify what maybe the intent of it was, but it just didn't make it. So it is what it is. Okay, the next one that was quite a lengthy debate on was talking about the EVSEs and ground fault circuit interrupter, as well as special purpose ground fault circuit interrupters, whether it's cord and plug or even hardwired. So y'all all are familiar with what the code says right now, right? With EVSE, if I'm going to, let's just use a garage. Let's keep it simple. If I'm putting a receptacle in a garage, again, 210.8 A is going to require it to be GFCI protected, okay? If you put a receptacle in there. And so in this case, it also says that all receptacles in 625.54 have to be GFCI protected. So we get this question all the time. If I put an EVSE, electric vehicle charger, let's just say in a garage, let's just talk garages, keep it simple, sweet. And I put a receptacle in there, and it needs GFCI protection on that for that receptacle. It does not matter what's built into the EVSE, whether it's CCID or whether it's its own ground fault protection. It's typically not going to meet the Class A requirement, which is the 4 to 6 milliamps. And because the NEC demands the protection of the receptacle, that means that nothing you plug into it can take the place of the requirement of the GFCI to be for the receptacle. Does this make sense? So that's why it doesn't matter what the EVSE has. It's a receptacle rule, okay? And so again, all 210.8As are receptacle rules. 625.54 is a receptacle rule. Okay, so in the 2026 provision, it was introducing to have the GFCI requirements to apply not just to the cord and plug for the receptacle, but also for the hardwired EVSEs. Okay, so significant change, because you hear manufacturers all the time say, we don't want our EVSE on a GFCI, a typical Class A GFCI, because non-compatibility issues, but it really has to do with the circuitry of the EVSE and what it's looking for, and its technology is a little different. And I won't get into the minutia But what I will tell you is that you had the major manufacturers of these EVSEs there advocating to say, look, we got problems with putting the EVSE, hardwiring it. We have real problems with the fact that if you're going to require GFCI on it, then it could cause issues. And we already know that charge point. I've got a call the other day from a guy who says it just will not hold. It will not. He's trying to meet the code. And it says right in there to hardwire it, not to put it on a GFCI. Because if you hardwire it, you don't have to comply with the GFCI requirement because it's not a receptacle in the garage, right? It's hardwired. So currently, in the 2023 edition of the NEC, 625.54 says all receptacles installed for the connection of an EV charger, okay, electric vehicle charger, shall have ground fault circuit interrupt protection for personnel. That means, again, that nothing built into the EVSE can take the place of this. This is a receptacle protection rule. Again, people lose a lot of sight of this. This is clear. If it's going to be a cord and plug to a receptacle, EVSE is going to require ground fault circuit interrupter protection for personnel. The GFI or the GFP or the CCID or whatever it is that's built into an EVSE cannot take the place of the 4 to 6 milliamp Class A GFCI requirement that is governed by 210.8A as well as 625.54. Okay, so the attempt in the 2026 NEC was to expand this now and say, okay, wait a minute. So let's give rules for cord and plug connected. For those receptacles, obviously cord and plug that are rated 150 volts or less to ground. Okay, that's your 12240 volt. That's all qualify under that. To have GFCI for personnel protection. So that's personnel, not equipment protection like a GFP or something like that. This is for personnel protection. Now, that's a typical Class A GFCI. 4 to 6 milliamps with the 5 milliamp nominal is what we're all familiar with. That's what that's calling for. Now, you do have receptacles that might be greater than 150 volts to ground, okay? Well, that is where they introduce what's called the special purpose ground fault circuit interrupter. Now, the thing to remember about those is the milliamp threshold, okay, are not to exceed 20 milliamps for personnel protection on those. Okay, so the ground fault trip current can exceed 20 milliamps. I remind you that they do make some that do go these. They do have like Class B type GFCIs that'll go higher than 20 milliamps. But this is critical because it says that look, if it's greater than 150 volts to ground, all receptacles rated greater than 150 volts to ground shall have SP GFCI, and basically that's just a higher milliamp threshold. Okay, so you have these two requirements for the cord and plug. Okay, it's not dictating anything to do with the amps or anything like that. It's very specific. Okay, it's just dealing with 150 volts or less to ground, and then greater than 150 volts to ground. Both when you're dealing with receptacles, you're going to have either regular Class A GFCI, or you're going to have a special purpose GFCI, which has a higher milliamp threshold. It just is not exceeding 20 milliamps, okay? Well, what was introduced here for the 2026 is to try to introduce, in the second draft stage here, was trying to introduce permanent wired EVSEs. So it has the same provisions that are 150 volts or less to ground, and of course greater than 150 volts to ground. But these, rather than talk about receptacles, this one's now talking about outlets. And again, this is where I try to explain to people, and those people that listen out there to these podcasts who are other educators who want to try to change the terminology of outlets. I think it is very clear here in 625.54 that when they talk about receptacles, they're talking about devices. When they're talking about outlets, they're talking about the actual EVSE, even if you hardwire it, because that is a point in the system where the branch circuit is being run to this piece of equipment, which is an appliance, and that is the outlet now. That's where the power is being taken from the building wiring to supply an appliance, in this scenario, the EVSE, okay? So that is a permanently wired, hardwired appliance. Now, you have two provisions here. It was permitted, permanent wiring, 150 volts or less to ground. It says all outlets, and that basically slang for saying hardwired EVSEs, rated 150 volts or less to ground, installed for the connection of EV charging, shall have GFCI protection for personal protection. That is not something built into the unit. That's not CCID. That is not the GFP or equipment protection or something that may be built into it. This is requiring it for the permanent wiring. Okay, so it all has to be protected in this case. So and also, unless the manufacturers change something in how they produce their protection, even in hardwired scenarios, they're going to have to make sure that they have something that is equivalent to a Class A for personnel protection built into it. So it just means the manufacturers are going to adapt. Now, greater than 150 volts to ground, again, same language, same concept, same SPGFCI with the not exceeding 20 milliamps has to be built into the system. Okay. Now, we do have some exceptions. This, again, is not going to be required for where you have DC charging. It's not going to require the SPGFCI. That's a very high level. They don't really have any devices going to do that. Okay. And then, of course, outlets that are installed for electric vehicle bidirectional charging shall not require SPGFCI. So you have some of these new equipment like the, I can't think of the name of the company that makes these things. But they have the ones that are designed now to be hardwired that are bidirectional. It's not only charging the vehicle, but can actually be used as an energy storage system. Okay, those would not be required to be SPGFCI, and typically they're going to be obviously greater than 150 volts to ground in those type of systems. Okay, the way they get utilized. All right. So anyway, at the end of the day, we have these provisions now for hardwired applications. Now, fast forward to the NITMAM. So the NITMAM was saying, wait a minute. Manufacturers are very aware that there is this possibility that they're not going to work. And that the interconnection or the compatibility between the EVSE on these permanently wired units are going to potentially cause a problem that they are not ready to overcome yet. This is CAM 70-178, by the way, and there was quite a few of these that were lumped together, so they're all pretty much targeting the same thing. So basically, the motion was to reject the second revision, which was 7875, if you want to go look that up. And it was for 625.54. The CAM, again, is 70-178, but it wanted to strike the permanent wired provision. It wanted to leave the receptacle application for all receptacles, but it wanted to strike all of this other information. Now, the reason for this, and a lot of the manufacturers, Tesla, different ones came up to the mic and said, look, we know there's issues. And the GFCI standards, which is UL 943, is working on a high frequency, a bunch of other things. Now, the manufacturers of the GFCI says we already have the special purpose. Basically, that's just a higher milliamp threshold, by the way. They're just calling it special purpose, but it's really kind of like a limited threshold class B GFCI, if you will. So anyway, they already have that. So they were passionate about, look, we already have this. This is fine. The problem with it was that the manufacturers of the EVSEs came to the mic and said, look, we are going to tell you that our units, if you hardwire them, which is now a way you can do it without GFCI protection currently in the 2023, if you hardwire, you're going to have problems. And our literature states not to put it on GFCI if you hardwire it. So it's one of those situations where we're going to create possible issues here because the major manufacturers say they're not ready yet. I mean, they won't work because of some different. It's not so much of an incompatibility thing. It is how the EVSEs function and how they work and how they work in the system that's causing the problem. They're saying it's not so much. Stop calling it an incompatibility thing or something like it. It's part of the way that these EVSEs work. Well, the code panel sent the message to them and said, well, no, you're going to fix it. And any permanently wired EVSE in the future is going to have GFCI protection or SP GFCI protection, depending on the volts 150 volts or less to ground, or will you exceed 150 volts or less to ground, whether it's, permanently wired, you're going to have GFCI or SP GFCI. And for the receptacles, you're going to have GFCI or SP GFCI. That's it. And so that was what was accepted. So that's what they got. So it means that the manufacturers of these EVSEs are going to have to scramble, because once this 2026, they didn't put a sunset date. They didn't say as of September 1st, 2029. They didn't do any of that. So that means that in the future, it resolves that question of whether or not you have to have GFCI on the EVSEs. The answer is yes and yes. You're going to have it, whether it's a normal Class A or an SP GFCI, depending. Okay, you're going to have it, whether it's receptacles or hardwired. That's where you're going. Okay, so those that want to look that up, that is CAM 70-178 when it comes up, but that does encompass quite a few other ones as well. So keep you in mind. Okay, so the next one that was important, I guess, for everybody out there is the ever controversial, the GFCI requirement on outdoor outlets. And remember, for those out there that don't know what an outlet is, it's a point in the system where you take power from the building. It is not a receptacle. That is a device that mounts in an outlet box. But that does not mean that a piece of equipment, an appliance mounted on like an EVSE, or even a disconnect, which people can argue that's different. It's still a point where you're taking it from the building system and then you're supplying some piece of appliance or utilization equipment. That is considered an outlet by definition. Okay, so a good example of this was in 210.8F, outdoor outlets. Again, don't confuse that with receptacles alone. There's already requirements for receptacles in 210.8A outdoors, as well as in B for other than dwellings outdoors for receptacles. Already have that requirement. This was where the people were, the one that's the biggest about this is the HVAC equipment. So you come out of the building and you hit a disconnect and then it whips down to your HVAC equipment. We had a relaxation and exception to 210.8F that came about in order to say that, look, GFCI protection shall not be required for listed HVAC equipment. This exception shall expire September 1st, 2026. Well, the manufacturers of these HVAC systems, which generally have some kind of effect where they generate a very high frequency and they're uniquely designed in order to handle what some of these HVAC units are generating. And then they were talking about the hazards of an HVAC system shutting down and all this kind of stuff. I all thought it was kind of bogus because nobody's reported any type of issues from that scenario that I'm aware of. Again, they tried to do some studies, but at the end of the day, the question really was, they want to extend this out to the September 1st, 2029 and let you not have to put GFCI protection on these HVAC units outside under this exception number 2. That was the crux of the change, right? And of course, introducing another exception in there, trying to introduce that when it comes to listed Class C SP GFCI protection shall be permitted for HVAC, the special class, yada yada. So there was an informational note that talks about HF plus, do not trip with it. So it's based on frequency. So that's what they wanted, right? Well, I tell you, the folks at the NITMAM were not buying any of it. The big argument was that for 3 cycles now, they've kicked this can down the road saying, give us 3 more years, give us 3 more years, give us 3 more years, give us another cycle. We'll solve this thing. We'll solve this thing. Understanding that UL 943 is still in the works and they believe they have some resolutions to this, but nobody knows when that update's coming out. Nobody knows if and when. So the members that were voting drew a line in the sand and said, you know what? We're not going to kick that can anymore. You better solve this thing by September 1st, 2026. So again, they're going to have to solve it by September 1st, 2026. They did not get an extension for that exception to go one more cycle. it has to take place. Now, they may appeal this. They've still got time to appeal. I guess they could appeal it because, look, if they're saying they can't do it, they can't do it. We have a problem. And then we're back to where we started, where the GFCIs keep tripping, and then local states will have to write amendments on their own to try to give them time. And we really don't want to go that direction. But anyway, the voting members said, no, I'm sorry. September 1st, 2026, get your act together. We're tired of kicking the can down the road. So that's what you got. Oh, by the way, for those that are following along in that one, that was, let's see here. Which cam was that, by the way? That was 70-160. Okay. So 70-160 was the one dealing with that application. So if you want to go look it up. And by the way, it is in the NEC 210.8F. The committee comment that this amendment is to, this cam is to, is 7584. And that's a committee comment, by the way. So if you're in Link or not Link, TerraView, and you're looking up these different things, that's the one that it's addressing. That's what the CAM was trying to address, okay? And it was all about the expansion, right? Now, we're still going to have the exception number 3. We still have they're going to have the allowance, I believe, for the Class C SPGFCI protection for listed HVAC equipment. I believe that is in there. If it's Class C SPGFCI provided, that type of thing. And it's got to have a marking on it. It says, warning, Class C SPGFCI protection provided for HVAC units. So again, that's not going to be misconstrued, okay, as something else, for something else. So they're kind of making that very clear in that application, what's going on. Okay. Now, again, if you want to check that out in your code book, and it's 210.8. And when you get into looking at the significant changes, or you're looking at what was proposed, that exception number 3 is going to make it. Okay. So they do have an avenue here, and the manufacturers will have to use a listed Class C, and it's got to be marked as such so that it doesn't get used in something else, because obviously this is going to have a higher milliamp threshold. It's obviously going to be basically HF or HF plus, and that type of thing. It's not frequency specific, that type of thing. Okay. All right. So look for that. But other than that, September 1st, 2026 is when that exception, basically the exception on all listed HVAC equipment in general, the exception to not put it on GFCI in general is gone. Okay. So manufacturers will have to sort that out, I guess. So again, that was CAM 70-160, in case you want to go read a little more into the details of it. Okay, let's see. What else do we have here that we want to look at? Okay, another very high profile CAM that was submitted was CAM 70-106. And this one was to change the minimum size of conductors in the NEC. As you know, we have typically for decades now, it's a minimum of 14 gauge copper and 12 gauge aluminum and things like that. So there was an effort in the code. And so this was CAM was to accept the public comment 1395. Now 1395 was a public comment to move it back to traditional minimum sizes of conductors that we've had for decades, right? Y'all are familiar. Minimum size was 14 copper, 12 aluminum, and 12 copper clad aluminum. And so in the 2026 second draft, they actually reduced it down to allow 16 gauge copper and to allow 14 gauge copper clad aluminum in the minimum size of 12 gauge aluminum. So they reduced the size of copper clad aluminum for the minimum sizing used in a dwelling. And they reduced the 14 down to a 16, which would basically be utilized for those 10 amp branch circuits. And everybody's been talking about the addition of the 10, 15, and 20 when you see a lot of code references where it's now talking about overcurrent protection. And we're talking about protecting of conductors that are, 10 that can handle 10 amps, right? And so that's what a 16 gauge copper, and that's what the 14 gauge copper clad aluminum, those type of things, as far as minimum circuits. Well, that went to the committee, and so the room had a very spirited debate on this, and ultimately it was very close, a 236 to 231 vote, but they chose to revert it back to what it has been forever. And that would be, it actually passed, the motion passed, and it puts it back to require that the minimum sizes are 14 gauge copper and 12 gauge copper clad aluminum and 12 gauge aluminum. So basically it pretty much nullifies anything that would allow you to use smaller sizes on the normal branch circuits that are in a dwelling. So we're pretty much back to a 14 gauge, 15 amps application. And if you want to do it in aluminum, you're going to use a 12. And if you want to do it in copper clad aluminum, it's going to be a 12. So that's what took place. And that was CAM 70-106. And that was 310.5A. And that's really about the minimum size of conductors within the scope of the NEC. So you're not going to have branch circuits that are going to be smaller than a 14 gauge copper. Now, again, obviously there's exceptions to this when we're talking about the fixture wire going down to a luminaire. That's different. We're talking about when it comes to the building wiring. So you're going to have 14 copper as a minimum for copper. 12 is a minimum for aluminum, and 12 is a minimum for copper clad aluminum. And that's how the vote went. It was very close, but that's what it went for the 2026. That's what you've got there. Okay. All right. Let's see what else. Oh, there also was one, I think it was submitted as well. This one was for table 31016. This was CAM 70-105. And this again was going to challenge the ampacity tables and remove the 16 and the 14 gauge copper clad aluminum and the 16 copper, to remove those. And so I think what happened is 310.5A came up first. And since, the 310.5A, which is CAM 70-106, came up first. And since it requires that the 14 is the smallest for copper and 12 is the smallest for copper clad aluminum and aluminum, that it made the vote on the 70-105 irrelevant. Okay. So there was no need to change the ampacity table because it's pointless. You could still, it's still going to tell you that a 16 copper is good for 10 amps. Possibly it might still tell you that a copper clad aluminum 14 is good for 10 amps, but for use in building wiring, it's irrelevant because we know what the sizes are now. It can't be for copper. It can't be smaller than a 14. And when it comes to copper clad aluminum or aluminum, it can't be smaller than a 12. So it really makes it a moot point. And to be honest with you, all those other areas that talk about 10 amp circuits really makes it a moot point there anyway, moving forward with that. So that's the significance of that one. And lastly, we'll talk about the one that you heard me talk about. This was CAM 70-93 when it comes to that 422.5B list of where you're going to have the protection, the GFCI protection on things like ranges, wall mount ovens, counter-mounted cooking units, clothes dryers, and microwaves. Okay, so kind of convoluted in what happened here. It actually got kicked back to Code Panel 17. We have to do a vote. I don't know the reasoning for this. I actually missed this one because I had a call I had to be on for one of our customers. But my understanding is this has been kicked back to Code Panel 17 to review, but I also heard that they also kicked it back to Code Panel 2 and possibly them retain jurisdiction over it. And if it does, one of the things that's always a problem is if 210.8D says that you have to supply these branch circuits with GFCI protection, then it really doesn't matter what we say in 422.5, does it? Because if it's in one place and it's not in the other, then it's always going to be an issue where the AHJ is going to say, well, it's right here in 210.8. So the argument is who has the jurisdiction over this? So I'm believing, here's what I'm thinking is the rationale behind this one is I think that they want Code Panel 17 to agree with Code Panel 2. They want Code Panel 2 to be able to say, yes, we want these appliances to be GFCI protected. And I don't believe, I still believe there's compatibility issues. I still believe that UL 943 is a ways away from giving us guaranteed non-compatibility issues. And so I can't really forecast right now where that's going to go. So right now you just have to assume that you're going to have to protect those locations. Obviously, you're in the 2023, you're going to have to provide GFCI protection to those things. You're going to have to provide them to the ranges, wall-mounted ovens, counter-mounted cooking units, clothes dryers, microwave ovens. You're just going to have to do it until we get this all sorted out. Okay, and I expect Code Panel 17 to have to vote here in the next couple weeks on this. I would think, based on the chair who submitted a letter, that they believe that there is significant compatibility issues, and we cannot get the answers from any individuals that are on UL 943 when it comes to GFCI and what it's going to be. We don't know when it's going to be published. So Code Panel 17 has a problem with putting things into the code where we know that there's issues. Whereas Code Panel 2, which obviously a lot of the manufacturers of these devices sit on, they're like, no problem. It needs to be there. I don't know if they're ignoring the compatibility issues. They just don't want to acknowledge them. I don't know. But we know there's issues because, look, we have very knowledgeable people that sit on these panels. And on 17, we have some individuals that are on those task groups that are working on UL 943, and they say they're not ready yet. They're not there yet. There's still the issues of this potential compatibility issue. But the people on Code Panel 2 say, no, we're manufacturers. We can handle this. We know we got the breakers that'll do this or the devices that'll do this. But for some reason, that information is not making it to us at 17 with any validation. So again, where are we at on this one? We still are going to get a vote. Code Panel 17 voting members are going to vote and see how that shakes out. And then it's hard to say what's going to happen in Code Panel 2, whether they're going to retain that or not. But we'll keep you posted. All right, folks. On Coffee Hour, we'll be talking about answering questions. If this generated any questions for you that you want to ask me, please do me a favor. Join us every morning at 8 a.m., Monday through Friday, Eastern Time, for Coffee Hour, where we'll chat about this week. We'll talk about changes. I can't talk about some of the other ones here. You might ask for other ones if I wasn't in the room. Again, Kevin Porter was with me. He's voting as well. I was in and out because I had customer issues that I was dealing with. And so it's just, kind of having to do business. So I'm voting as I can, trying to make sure I voted on ones that were very significant and in and out and trying to juggle many hats. But we did the best we could on this. So hopefully I covered the majority of the key topic ones today. And, we'll see what'll happen. All right. All right, folks. Till next time, stay safe. God bless. And we'll catch you on another episode of Mastering the NEC. Peace.
Thanks for tuning into another electrifying episode of the Master the NEC podcast. We hope you're feeling more powered up and ready to tackle the electrical world with the knowledge and confidence you need to succeed. Remember, in the electrical trade, knowledge is power, and we're here to make sure you stay plugged into the latest insights, tips, and code updates. If you enjoyed today's episode, don't forget to subscribe, leave us a review, and share the podcast with your fellow electricians and industry pros. Until next time, keep your tools sharp, your circuits clear, and your mind focused, because here at the Master the NEC podcast, we're all about sparking your success. Stay safe, stay smart, and keep mastering the trade. From all of us here at Electrical Code Academy, thank you for all your support, and we will see you on the next amazing Master the NEC podcast episode.